19.5 or 20 degree. Now addendum. What this addendum is? It is a radial distance of the tooth from the pitch circle to the top of the tooth. Addendum is, this is a pitch circle and it is a radial distance of the tooth from the pitch circle to the top of the tooth. So this is called as a radial distance from the pitch circle to the top of the tooth. This is called as a addendum. While dedendum, it is a radial distance of the tooth from the pitch circle to the bottom of the tooth. So from the pitch circle to the bottom of the tooth, whatever the radial distance is being there, that is called as a dedendum. Now addendum circle, it is a circle drawn from the top of the teeth and is concentric with the pitch circle. A circle drawn from the top of the teeth and which is concentric to the pitch circle, that is called as a addendum circle. Now dedendum circle, it is a circle drawn from the bottom of the teeth and it is also called as a root circle, and obviously it is also concentric to the pitch circle. So dedendum circle, it is a circle drawn from the bottom of the teeth and this is again called as a root circle and it is concentric to the pitch circle, right? This is many times called as a root circle also. Now you have to remember that is root circle or dedendum circle diameter is equal to pitch circle diameter multiplied by cos phi, where phi is the pressure angle. So this relation you should remember, that is root circle diameter or dedendum circle diameter is equal to pitch circle diameter into cos phi. Now circular pitch. So what this circular pitch is? It is a distance measured on the circumference of the pitch circle. Now again the pitch circle, okay, we are considering pitch circle. It is a distance measured on the circumference of the pitch circle from a point of one tooth to the corresponding point on the next tooth. It is usually denoted by PC. So what this circular pitch is? It is a distance measured. This is a circular pitch. It is a distance measured on the circumference of the pitch circle from a point of one tooth to the corresponding point on the next tooth. So this particular distance, it is called as a pitch circle and it is generally denoted by PC. Mathematically, circular pitch PC is equal to pi into d divided by t, that is pi d by t, where d is the diameter of the pitch circle, d is a pitch circle diameter, t is the number of teeth on the wheel, So if we consider d1 and d2 are the diameter of the two meshing gears and having teeth t1 and t2 respectively, then for them to mesh correctly, PC is equal to pi d1 by t1 is equal to pi d2 by t2. So in short, we can say d1 by d2 is equal to t1 by t2. So in short, it is not so that any two gears can mesh with each other perfectly. For them to mesh with each other perfectly, their circular pitch must be same, that is pi d1 by t1 is equal to pi d2 by t2, or this relation must be get satisfied, that is d1 by d2 is equal to t1 by t2. So this particular relation we can use for deciding the number of teeth on the meshing gear or for deciding the diameter of the two meshing gears. Then the next term which we are going to see, that is a diametral pitch. It is the ratio of number of teeth to the pitch circle diameter in millimeter. So diametral pitch, it is the ratio of total number of teeth to the pitch circle diameter. The pitch circle diameter means the very same which we have seen in a millimeter. So it is denoted by PD. Diametral pitch, PD is equal to T by D, pitch circle diameter, and T is the number of teeth. Now as we know, PC, that is a circular pitch, is equal to pi D by T. So if I say D is equal to PC into T divided by pi, and if I put this value over here, what we get PD is equal to pi by PC, where T is the number of teeth, D is the pitch circle diameter, and PC is the circular pitch. So diametral pitch is equal to pi by circular pitch, or we can say diametral pitch is equal to total number of teeth divided by pitch circle diameter. The next important term which we are going to see, that is a module. It is a ratio module. It is a ratio of the pitch circle diameter in millimeter to the number of teeth. It is usually denoted by m, or mathematically module m is equal to d by t, or we can again say module m is equal to 1 by pd, because 1 by pd, because pd is what? T by d, right? So this module, these terms, that is diametral pitch, circular pitch, and the module, these are related to each other, and module, it is a ratio of the pitch circle diameter in millimeter to the number of teeth. It is usually denoted by m. Mathematically module m is equal to d by t. Now we will see the clearance. What this clearance is? It is a radial distance from the top of the tooth to the bottom of the tooth in meshing gears. So here two gears are involved, and the radial distance from the top of the tooth to the bottom of the tooth in meshing gear, this is called as a clearance. A circle passing through the top of the meshing gear is known as a clearance circle. So now when the two gears mesh with each other, what happens? The top of the first gear cannot directly come in contact with the bottom of the second gear, and there should be certain clearance should be provided, and this is called as a clearance. So what is this? If we consider over here, this is the top of the first gear, and this is root circle of the second gear, and if you see over here, top of the first gear teeth and the bottom of the, there is a difference distance between these two, and this is called as a clearance. This is called as a clearance, and it is necessary for the smooth functioning and to reduce the wear and tear of the gear drives. So this is called as a clearance. And if you look at this particular diagram, so whatever the circle drawn through this clearance, this is called as a clearance circle. Now total depth, it is the radial distance between the addendum and dedendum circle of the gear. It is equal to the sum of the addendum and dedendum. Total depth, it is the radial distance between the addendum and dedendum circle. So total depth is nothing but, we know this is addendum circle and this is the dedendum circle or the root circle. The distance between these two, the radial distance between these two, is called as a whole depth or the total depth. Now working depth, obviously working depth is somewhat different. Then what this working depth is? It is a radial distance from the addendum circle to the clearance circle. It is equal to the sum of the addendum of the two meshing gears. So working depth if we see over here, as we know this is a clearance, so working depth will be addendum circle and the clearance circle. The radial distance between these two, this is called as a working depth, because this addendum circle of this gear and the addendum circle of the second gear will come over here, okay, and that's why this is called as a working depth. Tooth thickness, it is the width of the tooth measured along the pitch circle. So tooth thickness, it is the width of the tooth measured along the pitch circle. Width of the tooth measured along the pitch circle, this is called as a tooth thickness. Tooth space, it is the width of the space between the two adjacent teeth measured along the pitch circle. Tooth space, so it is the width of space between the two adjacent teeth. It is width of space between the two adjacent teeth. This is called as a tooth space. Tooth space. So between two adjacent circles, whatever the distance along the pitch circle is there, that is called as the width of space or tooth space. Backlash, so it is a difference between the tooth space and the tooth thickness. It is a difference between the tooth space and tooth thickness as measured along the pitch circle. So if you look at this backlash, what it means is it is a difference between the tooth space and the tooth thickness. So if you see, this is the tooth thickness and this is the tooth space. So if you see over here, there is a certain clearance between these two. There is certain space between this, and this space is generally called as a backlash. This space is generally called as a backlash, or the difference between the tooth space and the tooth thickness is called as a backlash. Theoretically, this backlash should be 0 for perfect operation, but generally this backlash cannot be kept 0. If this is kept 0, then there are the chances of jamming of two gears, and that's why in actual practice some backlash must be allowed to prevent the jamming of the teeth due to the tooth error, because while manufacturing there are certain errors in the tooth thickness, and also there will be certain thermal expansion. To accommodate this, there must be some backlash provided. Obviously this backlash must be minimum possible, but there should be certain backlash provided in the gear drives. Then face of tooth, it is the surface of the gear tooth above the pitch surface. So this is called as a face of the above the, it is the surface of the gear tooth above the pitch circle or above the pitch surface. This is called as a face of the gear. Then flank of the tooth, it is the surface of the gear tooth below the pitch surface. It is the surface of the gear tooth below the pitch surface, that is called as a flank. Below the pitch surface, this is called as a flank of the tooth. Top land, it is the surface of the top of the tooth. As the name indicates, it is the surface of the top of the tooth, that is called as a top land. This is a top land at the top of the gear tooth. This is called as top land. Then face width, it is the width of the gear tooth measured parallel to its axis. Face width, it is the width of the gear tooth measured parallel to its axis. So this is the face width. Width of the gear tooth measured parallel to the gear axis, this is called as a face width. Profile, it is a curve formed by the face and flank. It is a curve formed by the face and flank of the tooth, that is called as a profile of the tooth. A curve formed by the face and flank, this is called as a profile of the tooth. Fillet radius, it is a radius that connects the root circle to the profile of the tooth. Fillet radius, it is a radius that connect the root circle with the profile of the tooth, that is called as a fillet radius. And path of contact, it is a path traced by the point of contact of two teeth from the beginning to the end of engagement. So when two teeth are in contact with each other, two gear teeth are in contact with each other, whatever this point of contact, while rotating, whatever the path it traces, that is called as the path of contact.